Welcome back to AI Podcast. Today we're digging into a NeurIPS 2025 poster called SYMPHONY by Weizhu and Zhiwen Tang from Yunnan University. It's about getting multiple language models to plan together better than any one model can on its own.
Planning together as in a literal orchestra of models, right? The name kind of gives it away.
Exactly. The big idea is simple to say and tricky to do. Instead of relying on one model to drive a search process, Symphony uses a small team of different models and plugs them into a Monte Carlo tree search, or MCTS, loop. Then it adds 3 coordinating tricks so the team plays in sync.
Before the tricks, can you unpack the problem? What goes wrong when you just use one model?
Sure. Picture sending the same soloist on stage again and again, asking for fresh improvisations. You get variations, but they often circle the same melody. Single model planning has that issue. You keep sampling, but the branches in the search tree start to look alike. Exploration narrows and the planner gets stuck in familiar ruts.
So Symphony's fix is to bring in different soloists.
Right. Heterogeneous agents. Think one model that's cautious and thorough, another that's bold and creative, another that's great at summarizing. Each has different training data and inductive biases, so they naturally explore different parts of the solution space.
And you mentioned MCTS. Quick refresher for listeners?
MCTS is like scouting paths in a maze. You try some paths, learn which ones look promising, and spend more time exploring those. It balances exploration and exploitation. Symphony keeps that structure but lets different models propose and evaluate moves at each step.
Okay, now the 3 tricks. What's first?
First is how they pick which model to use next. They treat it like a multi-armed bandit and use an upper confidence-bound rule, so the scheduler favors models that have worked well so far but still gives others a shot. It's like a band manager saying, "Our sax player has been on fire, but let's give the pianist a solo because she hasn't had the spotlight lately and might surprise us."
Nice. Second trick?
Pool-wise memory sharing. When a rollout fails or succeeds, the on-duty model writes a short natural language reflection into a shared memory. Any model can read that later. No fine-tuning, no weights changed, just passing notes. It's like the ensemble keeps a little rehearsal diary so the next take avoids the same mistakes.
Love that. And the third?
Entropy-modulated confidence scoring. When a model evaluates a node, it outputs a value and a confidence. If the response is uncertain, high entropy, the score is down-weighted. Think of it as turning down the volume on shaky notes so one wobbly opinion doesn't steer the whole search.
Got it. So diversity to generate ideas, a fair way to pick who plays next, shared memory so everyone learns, and a confidence knob to keep the search steady.
That's the recipe.
What did they actually test?
3 settings that cover reasoning, acting, and coding. Multi-hop question answering with Hotpot QA. A simulated e-commerce environment called Webshop, where an agent has to find products by browsing. And code generation with MBPP, including tasks in Python and, interestingly, Rust.
And they had 2 versions of the system, right?
Yeah. Symphony S, the small one, uses open-source models you can run locally. Think Qwen, Mistral, Llama-class models. Symphony L, the large one, mixes in cloud APIs like GPT-4, plus other strong services. Same framework, different rosters.
So how did it do?
In short, strong. On Hotpot QA, the large configuration edges out established structured methods and a recent multi-agent baseline. On Webshop, it not only beats prior systems, but even surpasses a reported human expert benchmark. And on MBPP, it posts very high single-try accuracy for both Python and Rust.
Without drowning us in numbers, the story is consistent gains across tasks.
Exactly. And there's an efficiency angle. They often run with a modest search budget while other methods use much larger ones. Yet Symphony's search trees are smaller. Fewer node expansions to reach good answers. In the large configuration, they also cut cost by not always calling the most expensive model. Instead of leaning on a top model for every decision, they call it only when the scheduler believes it will help.
So it's like saving your star soloist for the tough passages and letting the dependable rhythm section carry the rest.
Perfect analogy. They even show the star is used only part of the time, but the overall performance still goes up.
I'm curious about the experimental setup. Anything unusual?
One detail worth noting is an Oracle feedback setting for Hotpot QA. The environment immediately says whether a chosen answer is correct. That isolates planning quality, which is great for diagnosis, but it can inflate results compared to messier real-world feedback. Also, they report averages over multiple runs, which is common for agent work, though it's not a full statistical deep dive.
Fair. And reproducibility?
They say code will be released and emphasize that the small configuration runs on consumer-grade hardware. That's encouraging for replication and for teams who don't have big budgets.
Let's zoom in on the novelty. Lots of people talk about multi-agents. What feels new here?
Two things. First, true heterogeneity inside a principled search loop. It's not just more agents talking, it's different models slotted into distinct roles of expand and evaluate, with a scheduler that learns which to pick. Second, the uncertainty-aware scoring. Downweighting uncertain evaluations is a simple idea, but in a search tree it helps avoid committing to flimsy branches.
And the shared memory feels practical. No retraining, just a note-passing system that tells the ensemble, don't do that again.
Exactly. Low engineering overhead, real planning benefit.
Any weak spots or open questions you'd flag?
A few. First, performance under noisier real websites or tools that sometimes fail would be a good stress test. Second, budget-aware scheduling could be more explicit. Right now, the scheduler learns utility, but adding hard cost and latency constraints would make it more production-ready. Third, agent pool design. Which models should you include for a new domain, and how many? Automating that selection would help.
And the usual safety questions. When multiple agents coordinate, you want to know they don't amplify risky behavior or biases.
Right. They mention robustness and fairness as future work, which is the right direction.
Stepping back, if I'm a practitioner, what's the actionable insight?
Don't just scale sampling from one model. Build a small, diverse bench and orchestrate it. Use a scheduler to decide who speaks when. Let agents share short reflections so the team adapts, and temper decisions by how confident the agent sounds. You'll often get better plans with less compute.
I like that. It's like moving from a solo sprint to a relay team with a good coach and a playbook.
Exactly. And because the small configuration uses open-source models, you can try the approach without committing to heavy API bills. Then, if you need the last few points of accuracy, you can add a premium model to the pool and let the scheduler call it only when it really matters.
Quick clarification on WebShop. You said it beat a human expert. That's in the simulated shopping environment, right?
Right. A controlled benchmark with specific goals and metrics. It's an encouraging result, but I wouldn't claim it's better than humans at shopping. It means the system navigated that benchmark's tasks more effectively than the reported expert baseline.
Good to keep expectations grounded.
Always?
Okay, takeaway time. SYMPHONY shows that mixing different models inside a search-based planner, coordinating them smartly, and calibrating their confidence yields both accuracy and efficiency gains. It's not just louder, it's better tuned.
And the future work is clear. Make the scheduler budget-aware, test in messier environments, explore multimodal tasks, and automate which models you recruit into the pool.
A real symphony. The right instruments, the right score, and a conductor who knows when to bring each section in.
Well said. That's it for today's AI podcast. I'm Ethan.
I'm Maya. Thanks for listening, and we'll see you next time.